This video will teach you how to work with functions and do basic operations with them, as well as finding the compositions of functions and finding the inverses of functions as well. This deals with a couple of the last sections in Unit 7. So I'm going to give you a couple of functions to work with on this first slide here, and we're going to figure out how they would combine using our four major operations: adding, subtracting, multiplying, and dividing. Now, a lot of this looks really fancy and difficult because of the function notation, but ultimately it's using the same skills you have worked with since pre-algebra. Most of it is combining like terms and distributing things properly. If you could do that, this will be hopefully pretty easy. So I give you two functions here: x squared plus 7 equals f of x, g of x equals 2x minus 9. So for each of these, we're going to go ahead and plug in the functions and determine how they would simplify. So first one says to take f of x, g of x, add them together. So all I'm going to do is write this out as an addition problem. So I'm just going to plug in both functions as I see them, put some parentheses around them in case I have to do more complicated math. But since it's addition, all I'm doing is combining like terms. So x squared has nothing to combine with. Same with the 2x. 7 and negative 9 combine to negative 2. And I've now added my two functions together with a result of x squared plus 2x minus 2. Subtraction is going to be the same idea. The only difference is, as you've learned with subtracting two expressions, the negative has to apply to everything after it. So make sure to distribute that negative. It'll flip the signs around. And then once again, you'll just combine like terms. X squared minus 2x, positive 16. And you've subtracted those two functions. Multiplication, same deal. But all you're going to do here, just like you did many times before this year, is distribute everything together because you are multiplying them. So the x squared will get distributed, same with the 7, and then we'll combine any like terms. So x squared times 2x is 2x cubed. X squared times negative 9 is negative 9x squared. 7 times 2x is 14x. 7 times negative 9 is negative 63. I get four different types of terms, so I have nothing to combine. There's my final answer. Division can, in a lot of ways, be the easiest because oftentimes there's not a whole lot to do, especially with these two expressions, which are binomials. If you have singular monomial terms, so something where it's just like 4x squared or 7x to the 9th, there are times when if they're singular terms that you can reduce them using basic exponent properties. When you have binomials, trinomials, etc., about the only thing you can do is try to factor them apart to see if anything cancels. If I look at the numerator, there's no way to factor x squared plus 7 apart. If I look at the denominator, there's no way to factor 2x minus 9 apart. That's as far as I'm going to get. So we're not going to do crazy amounts of division here. We're just going to leave that as is. That's as simplified as it gets. Now, what's a little bit newer is taking two functions and doing compositions. What a composition basically is, it's taking one function and plugging it into the other. So we see the notation where in 5 and 6 they look pretty similar to each other, but they're asking us to do two different things. Number 5 says find f of g of x. What that is telling us to do, so the inside parentheses is the g. That means the g is going to get plugged in to the x of the f function. So what I'm going to do, and you can see me circling this up top here, I'm going to take the g function, plug it straight in for the x. Everything else around that f function is going to stay put. So I'm going to plug in the g function where I see any x's, and then put everything else around it like I should. In this case, the 2x minus 9 becomes squared plus the 7. All I want to do from here is simplify as far as I can. As we've gone over many times, do not distribute the squared because you have a minus sign. Those are two different terms. You cannot do that with a binomial, so you have to write it twice. Once you do that, put your factors together by distributing. So we'll get 4x squared minus 18x minus 18x plus 81 plus 7. Combine your like terms, you'll get a final answer: 4x squared minus 36x plus 88. Now, for what we're doing in number 6, it's the exact same idea, except we're going to plug this in going the opposite direction. So what I'm going to do here, so I erase some of this out so we can see visually what's happening, is we are going to go ahead and take, since the f is inside parentheses here, we're going to go ahead and take the f function, plug it in for where the x is in the g function. So everything that we're going to have here is going to be the g function. That's what we're going to write out, but instead of x, we're going to go plug the f function because f is on the inside. So we'll have 2. In for x, we'll go the x squared plus 7 minus 9. Distribute the 2. We get 2x squared plus 14 minus 9. Combine our like terms, we get 2x squared plus 5. You get two vastly different answers, and a lot of times with two random functions, you will get two very different answers depending on the order in which you plug things in. But basically what this is, it's a fancier looking substitution problem, which you've done earlier in the year with systems. It's kind of the same idea. It's just that you're going to have oftentimes more variable terms left over. We're not actually solving for anything. We're just going to simplify. Again, the key is whatever's in the parentheses, the innermost function, that's the one that's getting plugged in to the function that's listed on the outside of the parentheses. So you're going to definitely want to practice with that. And you have plenty of examples in your notes to help figure that stuff out. Now, also with functions is the ability to find the inverse of a function. So we're going to take a look at a couple examples of that, and then we're going to combine it with the composition idea and put it all together here at the end. So we're going to first find inverses of functions, which is not actually as complex as it sounds. All of these functions are given to you where they're essentially set up so that they equal y, or in the case of number 3, f of x. We'll talk about that here in a second. The way to find an inverse is simple. First thing you're going to do is switch the variables. So number 1, I'm going to take y and x, trade places. Nothing else moves, just trade places with the variables. Once you do that, get y by itself again. When you do that, you're more than likely going to end up with a vastly different answer than when you started. So, to get y by itself now, I'm going to subtract 4. So I'll have x minus 4 equals 3y. Then I'll divide everything by 3. And that'll get the y by itself. That right there in the box is the inverse of the original function. So it's not that complex. As long as you know how to move pieces around to get a variable by itself, you'll be in good shape. Now, what you'll see is, especially in problems like 2 and 3, you're going to see some of those radicals and exponents that we've talked about. You're going to use some of those skills as well as part of this here. But again, as long as you know how to do opposite operations, do inverse operations, this should be hopefully pretty okay for you to work through. So, number 2, same idea. We're going to take the two variables and swap them around. Now we're going to go ahead and get y by itself. First thing we're going to do, the negative 7/4 is being multiplied by the y cubed. We need to move that first because, again, undoing a problem here, we look for addition, subtraction. There is none. We look for undoing multiplication, division. If we see something being multiplied by negative 7/4, could you technically divide by that? Sure. I would rather multiply by the reciprocal because it'll look nicer. So I'm going to multiply each side by negative 4 over 7. So I'll have negative 4/7 x equals y cubed. To get y by itself, if I have a cubed attached to it, I'm going to undo everything by taking a cubed root. So leaving with a final answer of the cubed root of negative 4/7 x equals y. So they might be weird looking answers, especially when you have exponents and roots involved. But again, it's all the same concept of using inverse opposite operations. Now, for number 3, it's the exact same idea. The only thing is I used function notation. As you might remember, as you hopefully remember at this point from learning in Algebra 1 and also this year, if you have f of x or g of x or h of x or anything x, that notation is just a fancy way of saying y. So what I'm going to do first is write a y in place of the f of x. It means the exact same thing. Reason why I do that is all I have to do now is switch the letters. And all of a sudden, this looks exactly like the problem we were dealing with in 1 and 2. So again, the goal is to get y by itself. So the first thing I'm going to do is, I'm going to make a little spacer so we spread our work out. We're going to go ahead and add 2 to each side. So I'll have x plus 2 equals the 5th root of y plus 8. In order to unlock what's underneath the root, we've got a 5th root. We're going to take everything to the 5th power. So I'll have x plus 2 to the 5th. Notice how I keep that all clustered together because I can't just directly apply an exponent when I've got a binomial statement like that. No, anything with a plus sign, we know we can't do that. Equals y plus 8. To get y by itself, I subtract 8 from each side. So I'd have x plus 2 all to the 5th minus 8 equals y. And that would be the inverse of my function. So in short, take the variables, change places, and solve to get y by itself. That's what it boils down to. The last part of this here is verifying if functions are inverses of one another. So in these problems here, I'm giving you two functions. We're going to determine if they are inverses. To determine if functions are inverses, we are actually going to do compositions. The way that you'll know that the two functions are inverses of one another is when you do both compositions, they both come out to a solution of x. So we're going to take a look here at each of these sets here to see which works, which doesn't. Maybe they both do. We'll see what happens. So I give you two functions in number one. We're going to do two compositions. If they both come out to x, that means they are inverses. If anything gets screwed up here, that's going to be a problem. So we're going to first start with f of g of x, which means I'm going to take the g function, plug it in for f. So this is what it would look like. So again, you're going to see the little bit of the work I'm going to show here with this. We're just going to cancel out what we can along the way. So 3 would get distributed to that fraction, but multiplying by 3 and dividing by 3 cancels. So I'm left with x minus 2 plus 2. Well, negative 2 and positive 2 cancel. That leaves me with x. That's a good thing. Now we need to check going the opposite way, g of f of x. So I'm going to take the f function and plug it in for g. So positive 2 and negative 2 cancel. I'm left with 3x over 3. The 3's cancel. I'm left with x. These functions are inverses because when you compose them both in each direction, you end up with x as your solution each way. Now let's check to see if that's the same in number 2. So we're going to do the exact same thing. We're going to do two compositions, f of g of x, g of f of x, and see what happens here. So f of g of x, take the g function, plug it in for f. So I'm going to have the cubed root of x cubed plus 5 with another plus 5 after. So if I simplify what's underneath, I'm already going to run into a problem. The 5's don't cancel, okay? Because I have positive 5 and another positive 5. That gives me 10. Problem is with this, I'm stuck. If they had been opposite 5's, I could have kept going, because I could have taken the cubed root of x cubed and been fine. But I can't take the cubed root of x cubed plus 10 and come out with anything nice. It's not going to whittle down to x. So this is a no-go, okay? This is as far as this goes. That means these are not going to be inverses. So all I have to see is one of them not work. I don't even need to check the second composition, because if one composition doesn't give me x, they're not going to be inverses of one another. So to determine if functions are indeed inverses, if I give you two functions, you're just plugging them into each other. The goal is to get x. If you get that, that's great. If you don't, that means it didn't work. So that's, in summary, how you work with functions to do some basic operations, how to find inverses, and how to do compositions of functions as well.